So this is about the orifice nozzle or the nozzle meter. So the orifice means if we separate two liquid like this one with a wall and a hole like this, so it will become an orifice nozzle or orifice. Orifice means you have a wall separate two liquid, and then this hole is the only flow rate or the only uh, way out for the liquid. So jadi nozzle orifice nozzle ni bermaksud kita buat nozzle, okey, dengan cara kita meletakkan satu flat plate macam ini, dan di atas flat plate tersebut ada nozzle untuk membenarkan aliran berlaku. So in this situation we have this orifice nozzle. So kita ada on the right side we have a 3 meter liquid. So and then for sure this 3 meter liquid, okay, will flow into this orifice nozzle, okay, and then the water will flow until both tank have same level. Okay, so and then the question is determine the flow rate through the submerged orifice shown in figure 5 if the contraction coefficient is 0.63. So please remember the idea of contraction coefficient here. So means that we have a nozzle like this one. So and then the water will flow, so it cannot take 90-degree curve. So means that the diameter here, the diameter of flow out the orifice is less than the diameter of the hole. So in this question, the diameter of the hole is given as 8 centimeter. Okay, the question can be solved like this one. So this is our diagram. So normally, so we need to think about the streamline first. So for example, we assume that we have a molecule here at the free surface. So and then this molecule, when the orifice here is open, so water start to flow, and then this molecule from zero, it start to move at certain velocity and then go through the orifice hole like this one. So this is point number 1. So and then this is point number 2. So because this is on the same streamline, so means it is okay for us to compare the energy from point 1 to point 2. Okay, so and then we list all the parameter for point 1 and point 2. So for point 1 here, for P1, the pressure, because it stay on the surface, so the pressure will equal to atmospheric pressure. So we assume that it is equal to 0. So and then the velocity, so it start from 0. So we take, so V1 is equal to 0 and Z is equal to 3. So what you need to do is you need to draw your datum. So let's say this is my datum. You could have another datum actually. So from this datum, so this height is 3 meter. So and then, so we go for point number 2 here. So for point number 2, pressure at point number 2 here is not equal to 0 because point number 2 here is not on the free surface. It is 1 meter below the free surface. So means that we need to calculate the pressure by using the idea of rho GH. So because it is not a free jet. Okay, this is actually the oil move or transferred from one tank to another tank. Because the water is inside a container, so we still need to calculate the pressure by using rho GH. So it is totally different with the idea of free jet or free water jet, because in free water jet phenomenon, the fluid move at certain velocity in atmospheric pressure, not inside a container. So and then the velocity V2 here is unknown, so mean we need to determine the value of velocity, and then the Z2 here is equal to 1 based on the datum. So please make sure that your datum, same datum need to be used for point 1 and point number 2. So this is my datum in this calculation. V1 equal to 0 because we assume that this molecule is start from the free surface, one, and the other one is at, let's say the orifice is closed in the beginning. So if the hole here is closed, so means that there are no moving, there are no velocity at all. So when the orifice here is open, so water start to flow. So means that this molecule, so it start from 0 and then it increase the velocity and finally it go through the orifice. So means that the starting point or the starting velocity of this molecule is equal to 0. This is our assumption in here. Okay, boleh? Okay, so and then we write down our Bernoulli equation like this one, substitute all the value, and then we could get that the V2 mean the velocity that go through the orifice is equal to 4.43 meter per second. So and then we could calculate the flow rate by using this equation, so we could get it is equal 0.014 meter cube per second. Okay, however, so this is the equation to calculate the flow rate, so A2 times V2. However, you must be very careful because the cross-sectional area of water is not the same with the cross-sectional area for the whole. So you need to use the effect of vena contracta coefficient here, contraction coefficient Cc, to determine the flow rate here. So the equation for Cc here, okay, it is you could get from this slide. Okay, it is equal to this one. So it is cross-sectional area of jet divided by cross-sectional area of the hole. So you need to have the Cc value 0.63 times with the cross-sectional area of the hole and then times the velocity. Now you could get the flow rate, the volume flow rate that pass through the hole is equal to 0.014 meter cube per second.